Okay, we would like to sketch the graph of a function that has the following properties. We have a limit as x goes to negative infinity. We have a limit, a one-sided limit that is negative infinity. We have another one-sided limit that is positive infinity. We have a two-sided limit that is 3. We have a function value, and we have a limit as x goes to infinity. So let's look at each of these one at a time and see what they imply about the graph of the function, and then put them together in a final answer. So the first one, the limit as x goes to minus infinity, so x is going to go all the way to the left, of the function is equal to -1. So if we consider the height -1 and we make a dashed line like this, this dashed line is going to be a horizontal asymptote for the function on the left end. Negative infinity is on the left end, so the curve is going to go down like that to the horizontal asymptote, or maybe it'll go up like that, one or the other. So that's typical behavior at a horizontal asymptote. Here we have a one-sided limit at x equals -1. So here's x equals -1. And we're coming at it from the left. And the function is heading down to negative infinity. So we have, in this case, a vertical asymptote happening at x equals -1. The next limit, we have x is also approaching -1, but from the right side, so from the other side, and the limit is positive infinity. So at this vertical asymptote on the right side, the curve is going to go up to positive infinity. This limit here, the two-sided limit as x approaches 3 is 1. So if I put an open circle right there, we just need to draw a curve on the left side of the open circle that attaches to the open circle, like maybe that. And then same thing on the right side, maybe that. And I got those numbers completely backwards. The x was 1. X was approaching 1, not 3. So let's just fix the numbers. And the f of x is approaching 3, not 1. I just got them backwards. So my proportions are off, but that's okay. I'll fix it in the final draft. And here we have f of 1 is equal to 4. That is a point on the graph. So x is 1, f of x is 4. So if x is 1, the y coordinate is 4. And that just puts a filled in dot on the curve. So it's a good thing we put an open dot here where x is 1 when we were doing our two-sided limit, because now we see that the filled in dot goes just above it. And the last limit as x goes to infinity is 2. That's a horizontal asymptote like we had for the first limit, but it's on the right end. X is going to infinity, that's this way, and the height of the curve is reaching 2. So there's 2. Let's make a dashed line. So the curve is going to have this kind of horizontal asymptote behavior. One of these on the right end. We have another horizontal asymptote. Okay, so now we want to put all this together in one graph. So on the left end, we had a horizontal asymptote at the height -1. And then at x equals -1, we had a vertical asymptote, and the curve was going down to minus infinity on the left side. So I think the best way to handle both of these asymptotes at once is probably to draw that. That has the horizontal asymptote at -1 and the vertical asymptote at -1 as x approaches from the left. Then we have a vertical asymptote on the right side of -1 as well. And then the next feature we had was at x equals 1, the curve has a limit of 3 and a y value of 4. So when x is 1, we have here, let's put this as 3, and then this is 4. The filled in circle is at 4. So let's come off of the vertical asymptote and just head right for that open circle because the limit was 3. And then at the height 2 on the right end, there was a horizontal asymptote. So let's just continue the curve past the open circle to make that horizontal asymptote on the right end. So here's a graph of y equals f of x that has all of the properties. The limit as x approaches negative infinity of f of x is -1, check. The limit as x approaches -1 from the left of f of x is negative infinity, that's here, check. The limit as x approaches -1 from the right of f of x is plus infinity, that's here, check. The limit as x approaches 1 of f of x is 3. That's a two-sided limit. So at x equals 1 from both sides, the curve has to approach the height 3. That's a check. F of 1 is equal to 4. That's this dot. And finally, the limit as x approaches infinity of f of x is 2. And that's this horizontal asymptote at the height 2. So the proportions are a little bit off. Here's -1, for example. That's a pretty big gap there. And this is 2. So the proportions are off, but the labels make it okay. You don't have to be an artist. But if you are and you care about better proportions, then I appreciate that personally. I'm just not very good at that myself. So the labels, though, are what validate the answer. Okay, so there's our function. And then one last comment. This is the graph of a function because any vertical line should cross at most one time. And that's why it's important here that we have an open circle with a closed circle, because then a vertical line through x equals 1 will only hit one point on the graph, the filled in circle.